Hi, welcome back to my shed. What I want to do in this lesson is take some of the ideas we've looked at to get us started with theme 11 about how temperature changes through geological time, and to start thinking about the effect that that has on sea level. Because sea level, as we know from all the current discussions about climatic change, does vary over time. It's not a fixed thing. So, we are aware that warming of the Earth's climate will melt ice caps and have a consequential effect on sea levels. There's an example here of the Larsen ice shelf in Antarctica, with large amounts of ice carving off the Antarctic ice sheet. But what effect will this actually have here in Wales? There are parts of Wales that are vulnerable to sea level change. This is a map of Cardiff and part of the Vale, showing the effect of a 1 metre rise in sea level. Relatively limited, but you can see places like Cardiff Bay, for example, some parts of Barry, would be vulnerable to this. If we see a larger rise in sea level, say 9 metres, we have a much bigger problem. Large parts of the city would be underwater. The Gwent levels between Cardiff and Newport would be completely flooded. A lot of the area so in and around Barry would also be inundated. If we take a more extreme view of a 50 metre rise in sea level, we can see that most of the city of Cardiff is now underwater, as are some of the more populated parts of the Vale of Glamorgan. But how likely are these? How much could sea level actually rise? Let's start by looking at the oceans. It's a quiz question that often comes up. How many oceans are there? If you look at this map, which is the same one that you have in your booklets on page 4, we're working here on pages 4 and 5 of your booklets. How many would you say there are? 5 perhaps? Maybe 6 if we count the Southern Ocean? Let me change something. When we look at this as geologists, how many oceans are there actually? For me, it's 1. There's 1 ocean. All the oceans are completely interconnected. There's no separation between any of them. So a change in one ocean, or a change in the sea level in one part of the world, will have a global effect. Now, all the water in the oceans, all the water on the Earth, is actually relatively small in comparison to the rest of the planet. Most of the water just fills up the lower parts of the Earth's surface. But how much are we actually talking about? We need to do some calculations to work this out. And we're going to start by looking at the total area of the Earth's oceans and seas. You have this data in your booklet. First thing I'd like you to do is to work out the total for me. So you need to add all of these figures together to get a total amount. When you do, put it into standard form just to 2 decimal places. Okay, we don't need to worry about sort of smaller bits of numbers here. These numbers are quite large. Okay, so standard form to 2 decimal places for the total area of the Earth's seas and oceans. We then need to work out how much ice we actually have on Earth. Now, most of the Earth's ice is actually only in 2 places, in Antarctica and in Greenland. If you look at these figures, you can see that Antarctica accounts for maybe 90% of the Earth's ice, Greenland most of the rest, with other ice sheets, in mountain areas, Himalayas, for example, actually only accounting for a very small amount. What I'd like you to do here is work out the volume of the ice. I'm giving you some average depth data, and there's also area data. Again, standard form to 2 decimal places. Okay, once we've got that, we can then start thinking about what volume of water the ice would create if, and it's a big if, all the ice on Earth were to melt. Now remember that ice takes up a greater volume than water. So the volume of water we get from ice is about 0.9 or 90%, if you prefer, of the volume of the actual ice. So if you take your answer and multiply it by for the volume of ice, work out what 90% of that is, that will give us the volume of water that will be released. Once we know that, we can now work out, if we spread out that volume across the whole of the Earth through that one ocean, how much would that make sea level rise? The big thing I want you to be careful of here is we really need that answer in meters. So do your conversion. Okay. Finally then, to finish off this lesson, what would that actually look like? What would we see as a result here in Wales? We've got a map here showing the height of the land. Can you draw in where you think the sea level would be based on your calculations and shade in the area that would be flooded? Okay, press pause now and have a go at those activities. See what you can come up with. Okay, let's see what you've come up with. So this was the data for the area of the oceans. If we add all those together, we get an answer of 361,132,000 square kilometres. Remember, it's about 70% of the Earth's surface. If we take that to 3 significant figures, that gives us 361 million square kilometres. And then if we're putting that in standard form to 2 decimal places, it's 3.61 times 10 to the 8. All those 3 answers are just different versions of the same thing. Okay. If we now calculate the total volume of ice on Earth, we need to work out the volume for each of these places. So if the average depth in Antarctica is 2.45 kilometres, multiply that by the area, and we get an answer 29,315,965 cubic kilometres of ice. It's a lot. In Greenland, ice is a bit thinner. We end up with 2,604,143 cubic kilometres. Add on the rest, and we end up with a total of 32,317,353 cubic kilometres of ice. If you put that in standard form, 3.23 times 10 to the 7. So that's the volume of ice that we're dealing with. That's all the ice on Earth. So if we then work out how much water would be released if all of that is melted, we need to multiply that by 0.9 to work out 90% of it, which gives us an answer of 2.91 times 10 to the 7 cubic kilometres. So we now know the volume of water we'd get if all the ice melts, and we know the area that volume would have to be spread out over. So if we do some division here, so that's the volume of water from ice divided by the area of all the seas at which it has to be spread out over, we get an answer of 0.08 kilometres. Convert that into metres, that gives us 80 metres. So that if all the ice on Earth melts, the most sea level can rise is 80 metres. You know, there is a fixed amount of water on Earth. That's as high as it'll go. That's as high as it can go. If we think about what that looks like here in Wales, if we draw a line just short of the 100 metre contour all the way around, you can see that it's a relatively small area here in Wales, but there are some areas that are particularly affected. Anglesey, Pembrokeshire, Gower, the Vale of Glamorgan and South Wales. We may think that, well, that's not a great deal of area, but if you think about where everyone in Wales actually lives, we live in coastal regions. The vast majority of people living in Wales would be rendered homeless by this. So, we now have an idea of the maximum amount of sea level rise there could be. Now, in reality, it's probably going to be less than that. There's a reason for that. I wonder if you can work out what that might be. Maybe that's a subject we can discuss when I see you back in class. I'll see you then.